Okay, now we are going to solve the given recurrence relation by using characteristic root method in discrete mathematics. Solve the given recurrence relation an minus 2 into 1 equal to 2 power n. N varies from greater than or equal to 1 and also given a not equal to 2 by using characteristic root method. What is given? The given recurrence relation is an minus 2 into an minus 1 equal to 2 power n, which means the given recurrence relation is non-homogeneous recurrence relation, and also the given that a not equal to 2. What is n value? N is greater than or equal to 1. If you substitute n, you get here a not, here you get 1, and also we get what? Positive sequences. Okay. So now we solve this problem by using what? Characteristic root method. What is step number 1? So before we find step number 1, first we have to verify the given recurrence relation is what is the order of the given recurrence relation. Okay. How to find order of this recurrence relation? That is nothing but order equal to what? Subtracting from highest term minus least term. What is highest term? an. So n minus least term n minus 1 equal to what? Minus n plus 1 equal to 1. So therefore the recurrence relation is what? First order recurrence relation. If you solve this equation, we get only one root values. Okay. So I'm going to find step number 1. What is step number 1? We find homogeneous solution. That means to find a n power h. H is nothing but homogeneous. So we consider this is equation number 1. So I'm going to write homogeneous solution of given equation. That means the homogeneous recurrence equation 1 is nothing but what? an minus 2 into an minus 1 equal to 0. Once right and 0, then it is called homogeneous and also it is linear equation. So next step, what is next step? Replace an equal to what? R power n in this equation. Okay, replace an equal to R power n. So we get what? R power n minus 2 in replace n equal to n minus 1. So we get R power n minus 1 equal to 0. Okay. So next step, I am going to take least term is outside. If we take least value power n minus 1, we take outside. From this equation, we get power n minus 1 into what? R minus 2 equal to 0. If base is same, we can add powers. You get R power n. Here you get 2 into R power n minus 1 equal to 0. So you bring this term right hand side. So we get what? R minus 2 equal to 0. Therefore, R equal to what? We 2. Okay. So this is nothing but what? This is called what? The roots of real numbers, and also it is different only. Okay. So therefore, is what? The root is real and it is okay. So we know what is a homogeneous solution for a roots and real and different. We know the formula. Okay. So that what? A n power h equal to a into r1 power n plus b into r plus etc. So here we have only one root. So I'm that is nothing but a into 2 power n. Okay, therefore a n h equal to what? A into 2 power n. Okay, so this is called homogeneous solution of given equation. Okay, okay. Similarly, we find the particular solution of our given equation 1. So what is step number 2? Step number I'm going to find what? Particular solution. That means we're going to find our p value. Okay. So this is called a particular solution. Before that, we have to identify given problem satisfied which type. So in this section, we have several types are there. I'm going to verify given problem is which type. Okay, which means first how to verify type 1. So we consider f of n right hand side. This is called f. So f of n is always a constant. If you get f of n is constant, we consider a n power p. What is our solution? A not only. But in this problem, this is not a constant value. Okay. So we are not using type 1. Type 2. Type 2 we consider f of n equal to alpha into b power n. Here we see 2 power n is there. So that I am going to consider that is alpha value is 2 power n. 2 na you get 2 power n only. Okay. And also we need to verify one more condition. Okay. So your b value, what is b value 2? Okay. So we need to verify this b value is a root of a given equation or not. Okay. What is a root of this equation? R value is 2. Okay, so we need to verify B value is 2. 2 is what? Root of this equation. So that we consider into n power m. Okay, how many times we get 2? Only one time, right? So that I'm going to verify what? B is a root of your equation. That means given equation. So how many times repeated? Only one times repeated. So we consider m. Therefore, we can the trial solution is what? A n power p. Okay, equal to a naught into what? 2 b power n into power m. What is m? M is nothing but number of times repeated. Here, 2 we have only one time repeated. So we get m value is 1. Okay, so therefore, given problem satisfied what? Type 2. Okay, so here f of n equal to what? Alpha into b power n. Alpha value is either 1, b value is 2 power n. Okay. And b equal to what? 2. 2 is a root of our given equation. That is 1. Okay. With of, sorry, b is what? B equal to 2 is a root of our given equation of multiple of what? Equal to 1 times. How many times we get r value to? Only one time. So one time. Okay, so then we consider, particular solution a n power equal to a naught into b power n into n power m. Okay, so we know a naught b value 4 power n into n power m value is only 1 repeated. Okay, so therefore this is our solution of what? Particular solution. Okay, here this is equation number 2. Now substitute equation 2 in equation 1. Okay, so we get what? What is equation 1? A n minus 2 into a n minus 1. Okay, substitute equation 2 in equation 1. So we get a naught into 2 power n into n minus, okay, 2 into what? A naught into 2 power n minus 1 into n minus 1 equal to what? 2 power n. Here you see equation number 1. 2 into n minus 1, 2 power n. Okay, so we get, solving this, we get the final answer. Okay, so I'm going to write this a naught into 2 power n into n minus 2 a naught 2 power n minus 1 into n. Now you multiply this term into this here. Next you multiply that term into second one. Okay, minus minus plus 2 a naught into 2 power n minus 1. Okay, only you get what? 2 power equal to what? Power n. Okay, so here you see the least term is 2 power n minus 1, right? So we take outside. So if we take 2 power n outside, we get into n 2. If base is same, we can add powers, you get 2 power n. Similarly, minus 2 into a naught n, okay, plus 2 into a naught n. I'm going to write this 2 power n is nothing but 2 power n minus 1 into 2. So here 2 power n minus 1 getting cancelled. We get only 2n into a naught minus 2n into a naught plus 2a naught. Okay, equal to what? Only 2. Minus 2n naught minus 2n a naught cancel. We get only 2 a naught equal to 2. Therefore, what is the value? A naught value is 1. Okay, substitute a naught equal to 1 in equation number 2, which means substitute here. Okay, so from equation 2 can be written as what? Equation 2 can be written as a n power p, that is equal to a naught into 2 power to what? So substitute n a naught equal to 1. So you get 1 into 2 power n into n. That is nothing but n into 2 power n. Okay, this is your particular solution. That means a n power p equal to n into 2 power n. Okay, now what is, how to write general solution? General solution is nothing but what? Adding particular solution and homogeneous solution. So step to find general solution, which means equal to what? Power homogeneous plus an power particular solution. What is homogeneous solution? That is nothing but what? Step number one. What is step number one answer? A into 2 power n plus homogeneous solution n 2 power n. So this is your an value. Okay. Uh, and also they given one more condition. Finally, they given a not equal to. Okay. So also given what? A not equal to 2. Okay. Suppose they are not give any initial condition. This is your final answer, which means this is your given equation. Okay. So now they given additionally they given some initial condition. So using this initial condition, we are going to find this constant value, a value. Okay. So substitute n equal to what? Is equal to 0 here. So we get what? A not equal to a into 2 power plus 0 into anything 0. Okay. So a not equal to anything power 0 1. Okay. So we can write this a equal to what is a not value? A not value is 2. Okay. 2. Substitute a equal to 2 in this equation. We get the general solution of given recurrence relation. Therefore, the general solution of equation 1 is what? An equal to a into what is our general solution? 2 power n. Okay. Plus n into what? N into 2 power n. So we know a value is 2. So 2 into 2 power n plus what? N into 2 power n. Okay. So here 2 power. So we take outside. So we get n plus 2 into 2 power n. Nothing but what? An value, which means the nth term of given recurrence relation. Okay. Which is called, that is nothing but the general solution of given recurrence relation is what? An equal to n plus 2 into 2 power n. I hope you are enjoying this session. Thank you.